This is the lecture for section 5C about statistical tables and graphs. Before we can talk about graphs, we have to talk about a table. And we're going to talk about a frequency table. A basic frequency table is going to have two columns. The first column is going to list all of the categories of the data. And then the second column is going to list the frequency of each category, or the number of times that data value was used. A die was rolled 20 times. The table below lists the results of the die. Create a frequency distribution. Well, on a regular die, we have the options 1, 2, 3, 4, 5, and 6. So then all I need to do is I just need to go and count how many of each happened. So 1 happened 1, 2, 3, 4 times. 2 happened 1, 2, 3 times. 3 happens 1, 2, 3 times. 4 happens 1, 2, 3, 4, 5 times. 5 is 1, 2, 3 times. And 6 happened twice. So this tells me the category or what the outcome was on the die. And then this one over here is the frequency. Once you have the frequency, you can calculate two more types of frequencies. The first one is called a relative frequency, which is basically going to give the result as a fraction, how many out of the total, which could also be rewritten as a percent. So relative frequency is going to be how many times that one value occurred divided by the total number of outcomes that you had. And the second one then is cumulative frequency, which is just going to continuously sum all the values that have occurred so far. So let's look at an example. We are still using that same die data, and we know we had a total of 20 outcomes in our data table. So to find the relative frequency, you're just going to take the number of times one occurred, 4 out of 20, and I can write that as a decimal, 0.2. Next one, 2 happens 3 out of 20 times, which is 0.15. This one is also 3 out of 20, or 0.15. 4 happens 5 times, so 5 out of 20 is 0.25. 5 happens 3 times out of 20, so it's that 0.15 again. And then 6 happened twice out of my 20 times for a value of 0.10. Cumulative, what you're going to do is you're going to go back to the frequencies, list the first one that you have. Now you're going to add this one and how much is in the next one. So 4 plus 3 is 7. So I'm going to take this value, add the 3 for the next row, 10. 10 plus 5 is 15. 15 plus 3 is 18. And 18 plus 2 is 20. So the total you have here, if you add all of these together, should be the same value you have at the bottom of your cumulative column. There are two types of data that we work with. Qualitative, which is categorical data, usually non-numeric. Sometimes there's a few things that are considered numeric that are qualitative. They're just explanatory numbers. So for example, your area code, if you have a 708 area code or an 815 area code, you're usually from the state of Illinois. You have a 219 area code, it tells people you are from Indiana. So even though it's a number, you can't find the average area code. So there's no like averaging or working with the numbers. So it's a qualitative piece of information. Quantitative data is what's going to happen if you count or if you measure. So we counted how many ones happened. We counted how many twos happened. Or you want to measure your hand span. That's going to be quantitative data, and we'll be able to find averages and things like that. So usually when we're working with that qualitative data, you're going to do what we just did with that frequency table. When we have quantitative data, sometimes the data is spread out a little bit further. So what we're going to do is we can group some data together in what are called bins. These next little examples are just going to ask, is it qualitative or quantitative? Brand names of shoes in a consumer survey. Well, you're going to answer with, I have Nike shoes or Reebok shoes or Adidas shoes. Those are going to be words, non-numeric, which are qualitative. Heights of students. Well, heights are something that you have to measure. So anytime you measure something, you are quantitative. Audience ratings of a film on a scale of 1 to 5, where 5 means excellent. So here we have a number, but that number relates to a word. So because it's relating back to a word, we are going to be qualitative. So 5 means excellent, 1 probably means poor, and then the numbers in between there are, okay, good, things like that. The other thing to note is that they are subjective or that they are opinion based. So anything like that, you can't really work with keeping it as quantitative. It would be qualitative data. So as you can see, there are number data that can be qualitative and quantitative. There is word data that is only qualitative. The following data is much more spread than our DICE data. Our DICE data was just the numbers 1 through 6. Here we're looking at 20 scores on an exam. So there's going to be a lot more spread of those scores. So what we can do is we can group scores together. And what we have to do is we have to make sure those groups are exactly the same width. So if you look here, 70 to 74, that is 5 values. 70, 71, 72, 73, and 74. The next group must also have 5 values. 75, 76, 77, 78, 79. And the same is going to be true all the way up here. And then what you do is you count how many values are in that group. So anything 70, 71, 72, 73, 74 is going to be counted here. And anything that's 85, 89 is going to be counted up here. And then we get our entire frequencies. All of these summed together should make our total of 20. We can then find our relative frequencies as well as our cumulative frequencies. The next question is then usually, is that the only way I could have done it? Did I have to group them in groups of 5? And the answer is no. We didn't have to do that in groups of 5. We could have done it in any grouping width as long as every single grouping has the same width. So here's another example with all the values in groups of 10. So all the 70s, all of the 80s, all of the 90s. And you can see we've got 3 90s, 6 80s, and 11 that were in the 70s. And then again, you could calculate your relative frequencies and your cumulative frequencies. So this part is kind of up to you as to how you want to do it, but most of the time, 5s and 10s are kind of what people generally tend to use. Once we've discussed how to get all of our data nicely into a table, we can now discuss what graphics we can use to represent that data visually. 2 of these are a bar chart and a pie chart, or a pie graph. Bar graph, pie graph. A bar graph is going to show each category with a bar whose lengths correspond to its frequency or relative frequency. We'll see some examples on the next slide here, and then we're going to actually practice how to make them. Pie charts are going to be in the form of a circle, and you have to use the relative frequency because that's going to give you the percent of the circle that is filled in by that category. So each wedge or section of the circle is going to be proportional to the amount of times that value occurred. Here you can see our data here is there were 4 A's, 7 B's, 9 C's, 3 D's, and 2 F's. There are a total of 25 values. And this first is a bar graph. So one thing I want you to note about the bar graph, there will always be a gap between bars when these are categorical data. The bars should not touch. And you'll see both forms here. On this side is the frequency. So this A graph goes to a height of 4. The B graph goes to a height of 7, C to 9, D to 3, F to 2. You could have, instead of using regular frequencies, used relative frequencies, and the graphs are going to still be exactly the same height. It's just that now they're going to be in terms of percentages. So A's were 4 out of 25, or about 16%. And those same percents can then be used to create our pie graph over here. And you'll see that the group that's the biggest, the C's, 36%, is going to be the largest piece of the pie. F's, which happened the least, is going to be the smallest piece of the pie. Now, bar graphs are easy to draw by hand, and you can do that. Pie graphs, not as much, just because sometimes getting those percentages is a little tricky. So we're going to learn about this wonderful software that we have called Statcrunch in just a second here. Some things to make sure that you have on your graph is a title, and that just explains what it is that we're looking at. So the grades on the final exam, maybe that's what that was, or final grades of the course. So that could have been the title for the previous graph. Vertical scale and title. So anytime you're creating a graph, you have to have an even scale. So if you're counting by 2s, everything counts by 2s. If you count by 5s, everything counts by 5s. You cannot skip around and go 2 and then 10 and then 50 and then 1,000. You have to keep the numbers evenly spaced to make sure that our graph is accurate. You also want to make sure you label what that side represents. Same thing on the horizontal side. If you have categories or numbers, those should be labeled there, as well as what the overall group represents. And then if you have something like a pie chart, you may have a key or a legend on the side. If it doesn't put the words in the pie chart, maybe just as colors, then the legend on the side would say, oh, the red represents your A's. The blue represents how many black ties you have. Okay. So now we're going to create a bar graph and pie chart from our dice data that we had. With your purchase of your Pearson access code, you have access to this program called Statcrunch. Super user-friendly. I find it much more user-friendly than Excel. So that's the one I'm going to show you. If you are familiar with making graphs in Excel, you have every opportunity to use Excel as well. But I want to show you this method here. So what you have to do is to access Statcrunch, you have to go into Blackboard. You need to log in, find our course, open up your Pearson tab. I always click Course Home. Give it a second. And then there's this link here called Statcrunch. And I'm going to visit the Statcrunch website so that I can do some calculations. Open. And now I'm going to just copy my data over here. So I have die is 1, 2, 3, 4, 5, 6. And then I have frequency is 4, 3, 3, 5, 3, 2. And we are ready to make our graph. So what I'm going to do is I'm going to go to graph, and we're going to start with a bar graph. So I'm going to hit bar plot, and we have a summary of data.
we have, anytime you have the frequency table, that's considered a summary. So your categories are the die, the counts is the frequency. And then just to show you here, we have the choice of doing a frequency or a relative frequency. We're just going to do a regular frequency graph, and I'm going to click compute. And what it's going to do here is create my graph. 1 happened 4 times, 2 happened 3, 3 happened 3, 4 happened 5, 5 happened 3, and 6 happened twice. Okay. We can also use this data if I wanted to. Actually, before I do that, let me open it back up. I'm going to click edit, and I'm going to change it to a relative frequency. You're going to see it's going to look exactly the same, except that it's the relative frequency values there. If you want to make a pie chart, you'll hit graph, pie chart, and again, we have our summary because we have all of our things summed together. So the die is the category, the counts is the frequency, and then I'm just going to click compute. So you can see in this graph, we have a legend because over here in the pie chart, it does tell me what each option was. It does tell me this is 1, but it also lists it on the side here. So 1 happened 4 times, which was 20%. 2 happened 3 times, which was 15%. 3 happened 3 times, 15%. And then you can see which color it is and which one it goes to. So you have the option to use Statcrunch in your homework to be able to create your graphs so that if it's like a multiple choice saying, hey, which is the correct graph, you can create your graph here and then compare it with what is on homework. I may also ask you on a quiz or test, or on a test, we don't do quizzes here, to make a pie graph, and I want you to save it and upload it for your test. So what you can do is you can do options, you can download it, you can copy it, you can save it to your computer so that you can upload it as an image on an exam. If you ever have questions about that, just ask me. If this was a little too fast, you can always rewind it. Or there's all sorts of, if you just search in Google or on YouTube, how to make a such and such a graph in Statcrunch, there are thousands of examples that you can watch. And I always encourage my students to do that if they think they need a little bit of extra help.
Usually, bar graphs and pie charts are used more frequently with qualitative data or small grouped quantitative data. If you have a larger spread of data where you've binned your data and like the exams, you're going to want to use a histogram. So these ones here, these histogram, a line chart, a time series graph, are going to be strictly numeric graphs, strictly quantitative graphs. So histogram is going to look like a bar graph, but it's for quantitative data. The bars are going to go in numeric order, and the bars are going to touch because there's a reason for that, because that data is numeric. A line chart is going to, some of you may think of it as like a scatter plot that's connected with a line connecting all the dots. So it shows a data value as a dot, and then it's connected with a line all the way through to represent kind of what's happening or how it's changing as you go from the beginning to the end. And a time series graph is a line chart or histogram in which the horizontal axis represents time. So basically, it's going to look like one of these two up here. It's just that if you're dealing with a span of time, maybe from 1990 to 2020, it may be a line chart, but if it's based on years, it's then considered a time series graph. Below is a histogram and a line chart for the exam data that we looked at on slide 10. We had grouped the data in bins of width 5. And you'll see it looks like a bar graph, but again, the bars are touching here for a specific reason. This first bar here represents the numbers 70 to 74. And then where this bar ends, the next one starts, because the next possible score is 75. So this bar ends at 74. The next one starts at 75. So it's just a continuation all the way through. Now, to turn this into a line chart, what they do is they put the dot in the middle of the bar. So in the middle, 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 in the middle. And that's how they're getting this. So if you look, this dot is right in the middle of this category. This dot's going to be right in the middle of this one. And then they connect the dots with a line. The table shows the ages at the time when they won the award of all Academy Award winning actresses through 2021. Make a histogram and a line chart to display the data and then discuss the results. So we can see here they're grouped by 10 values. 20 to 29 is 10 values. And then 30 to 39 all the way through. They're all groups of 10. And then over here is our frequencies. So 32, 34, 15, 3, 8, 1, and 1. The data is quantitative and again organized in 10-year bins. So on the next slide, I will show you the histogram, and then over top of that is going to be the line plot. And then we can discuss what we see. I know it does say it here, but I'm going to discuss it when we look at the actual graph. Here we have the 20 to 29-year-olds. You can see is up to a height of 32. Next group goes to a height of 34. Then we've got 15, 3, 8, 1, and 1. And in order to make the line plot, you're going to put the dots right in the middle like they did here, and then connect them all the way through. So some things that we see, again, this is a histogram, so the bars are going to touch. So we will always have that. And it looks like we are doing winning female actors. So it looks like really this group here is where our female actors are winning. Somewhere between the ages of 20 and 39 are our big winners. And if you're kind of over 40, you're not as likely to win the Academy Award. One thing we could do is then we could compare this against the men and see if there's a difference. But otherwise, actually, it does say it looks like men actually win older versus younger. So there is a difference between men and women who earn the best actor and actress. But hopefully this makes sense. We're going to go through an example here in Statcrunch in just a second.
We're going to create a histogram for the following data. And I say data specifically because this is all the raw data. It's not grouped for us in any specific way, shape, or form. We just have the following test scores. So I need to enter them in. Got 89, 67, 78, 75, 64, 70, 83, 95, 69, 84, 77, 88, 98, 90, 92, 68, 86, 79, 60, and 96. And you can see I've got 20 values here. That is all the way down on the 20th spot. Now, we have data. So when we create our graph, we're going to have to make sure we select data. I want to create a histogram this time with my test information. Now, what I'm going to do first is I'm just going to let it compute its graph. And it's going to make it how it thinks is best. And that is doing groups of 5. So 60 to 64, 65 to 69, 70 to 75, and that's how I did it, groups of 5. You don't have to use what they did here. If you want, you always have the option to say, I want to start at 60 and I want to go by tens. I want to put all the grade letters together, the D's, the C's, the B's, and the A's. Oops. And if I do that, though, it looks kind of funny. Look at that. There are 5 D's, 5 C's, 5 B's, and 5 A's. So that's actually kind of interesting. I kind of like this one better, but you can see here why that makes sense. 2 plus 3 is 5. 1 plus 4 is 5. 2 plus 3 is 5, and 2 plus 3 is 5. So if your homework asks you to do a specific start and width, you can do those here. We don't want that one. Okay, so that's a histogram.
This last graph here is a time series graph because on the bottom here is a time in years. And it shows the number of homicides in the United States per 100,000 people. So it says, briefly summarize what it shows. So before you move on, if you would like to add a comment here for what you see happening, and then you can look on the next slide and see if you were correct or not. Biggest thing we can say is homicide rates have clearly changed over time. They started pretty low at the beginning of our graph and then rose pretty steadily until, what was that, 1970, 1974, somewhere in there. Dropped down a little bit, kind of picked back up, and it kind of stayed pretty high. It kind of did a little bit of like a wave up and down, back and forth until about 1992, 93. And then it started to kind of fall back down again, where it definitely settled a lot lower. But it did look like it kind of did a little spike up at the very end there at 2020. So, not sure if you guys saw any or all of those things, but being able to look at a graph and read them is a really good thing. But this is the end of this week's assignments. We did 5A and 5C. So please make sure you do the Pearson homework and then the discussion board for this week. And I will see you back next week.